Alright, what's up guys? It's David Kim here with Algos Explained, and today we have a question from LeetCode. It is number 7 called reverse integer. This question was requested by one of your fellow viewers, and if you have a LeetCode question or a Code Wars question that you'd want me to do, go ahead and comment it or email me at algosexplained@gmail.com. Probably just commenting in a video would be the easiest, but yeah, you do what is easy for you, and I'll do my best to get to it. Maybe it'll be a whiteboard question, maybe it'll be a screen recording question, depending on how busy I am. But with that said, let's go ahead and look at this question. It is called reverse integer. Given a 32-bit signed integer, reverse digits of an integer. And I'm going to assume they want us to return, well, of course they want us to return that, but then do they want us to return it in an integer format? Or is it okay if we return it in a string format? It doesn't specify here. Of course, we know that they do want us to give us an integer, because if you do a string, it'll fail. And so that's how you know. You might want to just clarify that with your interviewer. And 32-bit signed integer, honestly, when I first read the question, no idea what that means. Like, I could Google it, or I could just keep reading. Luckily, in the note here, it tells us kind of what 32-bit signed integer represents. And it says, assume we are dealing with an environment which can only store integers within 32-bit signed integer range. And so this is the range for this 32-bit signed integer. And so they said that if the reverse, or whatever our reverse value ends up being, if it's outside of the range, then return a 0. And so this question is two-part. It seems like a super easy question. Just make sure you get the two parts of it. You take the number, you reverse the number, and then you make sure it's within the range. Because regardless of whether or not, and of course you can't do the range check, so you might be thinking, oh, maybe I'll just do the range check before so that I don't even have to do that whole, I don't have to run the whole function. No, you can't do that. You gotta make sure the reversed integer is within the range. So you gotta reverse it first. There's no getting away from that. Then compare within the range. And if it is in the range, great, return the integer as is true, negative, or positive value. If it's outside the range, just return a 0. And let's see, so looking at an example real quick, if we're getting 123, return 321. If we're getting negative 123, return negative 321. And so what we're going to do is we are going to change the integer into a string, because a string you can iterate through. With an integer, you can't separate the 1, the 2, and the 3. With the string, you can. And so we're going to change the integer to a string, and then we're going to iterate through that string, and we're going to build our reverse string, which is going to eventually be our output. And then we're going to change that back into a number, an integer, and then we're going to do the range check, and then we're going to finally return what we're going to return. And so let's go ahead and let's get the solution up here for you, and we're going to go through that. Alright, so we have a solution here, and I have two versions of it. It is exactly the same thing, almost, minus this is a ternary, and this is not. And so let's go ahead and work with this example first, and we're going to talk about it. So we're building a function here. They gave us x, but you probably want to make it into a num. If you're writing this into, like in an interview situation, like you don't want to use variables like x's, not because you want to prove to them, well, of course you kind of want to prove to them that I don't really use single letter variables, but more importantly, it's more important that you don't do that in an interview, only because, well, mainly because you're going to have to use that function, or you're going to have to use your function, and you're going to have to explain to them exactly what it does, line by line pretty much. And when you're having an x here, like imagine this was still an x, you might be, oh, you might be at the end of your code, almost done explaining it, and be like, oh gosh, wait, what was that x? You're gonna have to walk up your code again, and that's just a waste of time. You don't want to waste time like that. And so, you know, starting off with something nice like num helps you kind of remember it and better explain it as you are explaining it later. So, like we said, what we're gonna do is we're gonna take that integer num, and we're going to change it to a string, which is what we do on line 7 here, with the toString method. And so now num is a string. So we are string num here. we're going to create our new num empty string, and then now we're going to iterate through the string num, because now we can iterate through it, and we're going to build up our new num. Don't mind this code here, we're going to look at that. Line 14 through 16, we are building our new num. As you see in the meat of this for loop, we are plus equaling this guy. And one thing that I do differently in this for loop is we're actually moving backwards. You can do a lot of things with for loops. You just have to really know, okay, you're probably going to start with an I. That's just the format of it usually. You could use any variable, of course. People use I because I index, you're looking at index numbers. But you could set it to anything you want. And in our case, we set it to the last index of the number. And so let's go ahead, remove that. This is pretty much string num. And as we're going through that, we set I to the last index of it. So we're looking at that index that holds number 3. And our conditional is as long as I is greater than or equal to 0. And I know that when you use a for loop to move forward, you don't usually have the equal part of it. But if you're moving backwards, you need to have that. And of course, if you're doing all sorts of weird things with your for loop, just kind of know what the conditional is in general. But when moving backwards, don't forget that equal sign, because 0 stands for an index. And if you didn't have the equal sign there, if you erased it, then you would never reach that 1. So we want that there. And of course, we're decrementing because we are moving backwards. And so now as we move backwards, we are building up our new num. So this is our string num, and I is representing the number 3 right now, and so we add 3 to here. We added 3 to our new num. Now we're at the 2 because we're moving backwards. We add the 2 there. We're at the 1. We add the 1 there. Now if there was a negative at the very front of it, we're moving backwards. The negative sign is the last thing we see, and so our new num is actually going to look like this. And so you might be thinking, oh gosh, this is ruining our function, or our new num is now looking ugly. However, don't worry about it. Spoiler alert, parseInt takes care of that for us. When you parseInt a number, or when you parseInt a string, it'll ignore all the strings back here. It'll even ignore the numbers. Just as long as there are some numbers here, it'll just make that into a string for you, and pretty much new num is now going to be 321 in a number format, because we parsed it. Oh, actually, never mind. This is int num. So now int num is going to be this guy, regardless of whether it was ugly like this or just ugly with one negative sign. So that's good news for us. We don't have to worry about kind of morphing this into something that is suitable for parseInt. parseInt will take care of that for us. Bad news is no matter whether our original num was a positive or negative, our int num is now represented as a positive value. And so we have to keep that in mind, because we want to return a negative reverse number if it was negative to begin with. Just like how if it was negative 1, 2, 3, we want to return this as a negative. And they definitely won't take a trailing negative at the end, because that doesn't mean anything. So lastly, we take a look at, so one thing that we haven't done yet, we haven't done the boundary checks. That was the second part of our question. We reversed the number. We haven't even changed it back to a true negative or positive yet. It is just a default positive right now. And we haven't done the boundary checks. And so let's go ahead and do a portion of that boundary check right now. And so now my logic, I think, well, it works for this question, but it probably should be ironed out even more. Well, the first reason why I first only checked for the outer boundary was because this question said, assume that your function returns 0 when the reversed integer overflows. It doesn't say when the integer is out of range. It just says, they said, we're dealing with an environment which could only store integers within this range. Okay, so that's just a piece of logic there. And then this is what really matters for our question, our purposes now. For the purpose of this problem, assume that your function returns 0 when the reversed integer overflows. And in my mind, overflowing could only overflow positively. However, I understand, yes, you can go outside the boundaries negatively also, but I wasn't thinking all that when I first wrote it, and it turns out the LeetCode takes my answer, so a win there. But anyways, not a win if your interviewer is going to be nitpicking at the details, which hopefully you nitpick on yourself before they get to. But let's go over this ternary. Return. So this is our final return. This whole thing returns, the return encapsulates this whole logic here. And here we have int num is greater than or equal to pow. And as you can see, I didn't even account for this -1, which I do later, but regardless of whether I did or not, it did accept it still, for the purposes of LeetCode at least. So pretty much what I did was, okay, is our int num greater than or equal to pow? If it is, that means we're outside the overflow boundary, the positive boundary. And then we'll return a 0. If not, remember I said I didn't care about the lower boundary, so I just go ahead straight into checking, okay, was this a negative to begin with or not? And so num is it, and num, remember num is our original parameter here. Was our original number a negative? If it was, then we'll return the negative version of it. If not, we'll return that. And if num was just a 0 to begin with, this statement will be false and we'll return that 0. We won't be trying to multiply it by -1, although that wouldn't matter anyways. Another way you can technically think about the lower boundary is if int num was a negative number, what would that lower boundary be? That upper boundary and lower boundary are essentially the same thing, minus a negative. And so if we were to change int num into the true negative, then we would have to compare it against the negative version of this guy. And so would it really matter if we just compared the positive versions of it? Technically, it wouldn't matter as long as this -1 wasn't there. Like if the boundary was -2 to the power of 31 and +2 to the power of 31, then in that case, this logic definitely works 100%, because why make int num negative only to compare it against the math pow negative when you wouldn't have to. But anyways, there are other solutions. Probably you can go into like the discuss tab and look at how other people did their complete boundary checks, but I mean I didn't, and it worked here. If we go ahead and take this ternary into a if statement, if broken up into if statements, this is what it looks like. This first part of it, we're saying, okay, is the int num greater than or equal to pow, math.pow? And that is, I might not have mentioned this, that is exactly how you represent a power right there. And in this case, I did include the -1 just to see for fun. And of course, this still worked, because if this worked, then that's going to work too. So int num greater than or equal to math.pow. If it is, then return a 0. We're returning this, and so we just return a 0. Otherwise, this is another ternary. So this was a ternary in a ternary. If for the purposes of splitting it into ifs, it's just another if. If num is less than 0, and in this question, in the second format, I didn't change the x. If the original number is a negative, then we'll return the negative version. That's exactly what happened right here. If it was a negative, we returned the negative version. If not, we just returned int num. And so that is this question here. Hopefully that clears things up a bit. In terms of submission, it's all over the board. I honestly wouldn't trust this LeetCode thing to really give you a sense of my code is great. You should be able to calculate the time complexity by yourself. In terms of this question, I'm not exactly sure how much that takes, but this for sure is just the n. So I would say this whole function is just O of n time. Like if you check this out, I even got a 56, which is 99% better than everybody else. So it's really up to kind of the system on this time complexity. If you do, one thing that does help though is if your function is really inefficient, then it'll point it out very blatantly. But sometimes it's the same and sometimes it's just a matter of how well the system's doing. Okay, so that's it for this question. Hopefully you enjoyed it. Hopefully it cleared up kind of whatever questions were looming. If you enjoyed it, please like, comment, and subscribe, and I'll catch you in the next one. Bye.